Okay, it's about completing the square again. And completing the square looks something like this. Y equals x squared plus, let's say 8x plus 2. Now, is this one a perfect square? No, because this number and this number, I have a special relationship in a perfect square. It's called half-n square. I sometimes joke that it sounds like a little German boy's name. Half-n square, come here and eat your pudding. Anyway, so half-n square is half, this is 4 squared is 16. Can I just change this 2 to a 16? No, but I can put the plus 2 at the end and go plus 16 here. One more thing I need then. What? Yes. A minus 16. Good. That way, these have canceled each other out, and really, it's the same exact thing as I had before, and that's what you have to do in math. You can't just like add something to one side without balancing it out and add it to the other side. But this is a new way. We add it to this side, but we also subtract it from this side. Then this part right here becomes y equals x plus 4 times x plus 4, because that part factors perfectly. And then this part here would become minus 14. Final answer, x plus 4 squared minus 14. And I was playing around with this complete the square. What do you think that FV stands for? For the vertex. Because that's why we do this. We complete the square for the vertex. Because now I have the vertex, negative 4 comma negative 14. And that's what's cool about this, is I now have general form turned into vertex form, so now I know the vertex. All right. And by the way, if you know the vertex, the axis of symmetry is this right here. Normally, we're used to doing the other way around, where we'd have the axis of symmetry first. We have to figure out the other point. But if you get the vertex really quickly like that, you don't have to go through any extra work. You can just say, oh, x equals negative 4 is your axis of symmetry then. All right, so the new thing that I wanted to teach you for today, today is part 2 of Complete the Square, is what if it has a stretch factor? It's like this, 2x squared plus 8x plus 1. All right, first thing to look for is any number that is on the x squared, because we're going to pull that off. That's the stretch factor. So I go and factor just these two parts. Why? Because remember how my first step was always to move this plus 1 way over? And people think a lot of times that it has to have a 2 here and here and here, but it does not. This last number does not need to have a 2 on it. I can just factor this first part. So I'm going to factor this first part and make it 2 comes out first, x squared plus 4x. Now, again, normal factoring, I would find the biggest thing I could. I'd take an x all the way to the outside here, like this, 2x. Do not do that, because I want this to just pluck this number off and put it out in front. So it's different than normal factoring. Now I can continue my problem like normal. Half and square happens now, not at the beginning. It happens now after you factored out the 2. Half of 4 is 2. 2 squared is 4. So I go plus 4. And a minus 4, and don't forget this guy comes down, plus 1. Now I need a parenthesis here because that's the part that'll factor. Now this is the part that is so like I don't know, in addition to the normal process, you've got to remember that this 2 right here that has been factored out is now going to affect that 4. And that 4 is supposed to balance out that 4. Now all of a sudden this 4 got 2 times bigger. So to keep my equation balanced, I have to multiply this one by 2 also. That is the step that everybody tends to forget. All right, so the final answer is the 2 came out front. And now this part factors to x plus 2 and x plus 2, which of course can be put together and as x plus 2 quantity squared. And then this, not forgetting the 2 now, I'm remembering the 2, makes negative 8. Negative 8 plus the 1 makes negative 7. And the final answer is to actually put it all together, x plus 2 quantity squared minus 7, and now I know my vertex. I completed the square for the vertex. Because now I can tell it's negative 2 comma negative 7. And the axis of symmetry is that guy, x equals -2 is the axis of symmetry. Okay. That's called completing the square with a stretch factor. It also works if there's a negative. Let me show you one of those. Y equals -x squared plus 10x minus 1. All right, step 1. Always, in all these problems, move this over. -1 goes way over here. Got to have room. Okay. Next step. You look and see if there's anything on the x that needs to get factored out, and there is. It's a -1 right there. Do you get how there's really like a 1 in there? So this is -1 needs to get factored out. So I factor it out of just these two. That's another good reason to move that way over there so you're not tempted to factor the -1 out of it. Leave that -1 alone. -1 comes out here, and then I have x squared. And if I take a -1 out of positive 10x, I get -10x. It's really when you're taking out a -1, you are dividing by -1 here and dividing by -1 here. And I end up with x squared for this part. And I end up with minus 10x for that part. Okay, now it's half and square time. Half of the -10 makes 5, or -5. And then I square it, makes 25. And if I do a plus 25, of course, I have to do a minus 25. And then a -1. And -1, x minus 5, x minus 5, minus 26. I'm doing this on purpose. -1, x minus 5, quantity squared, minus 26. Oh, there we go. Good. One person. Okay, what are you talking about? Just saying there's a mistake in here, just for those following at home. Okay? What I did say, I'm doing this on purpose during my, because I knew there was something going wrong. But what's wrong? Where? This -25 right here has to be multiplied by whatever's out in front. So I multiply this times -1. So that should become positive 25. Why? Because it needs to balance out this one, which becomes -25. Okay? So positive 25 minus 1 makes positive 24. You are so right. And I was hoping somebody would catch that. Okay. Yes? You have to put the 1. What are you talking about? Oh, I see. Do you have to put this one right here? That one could be just a negative if you want, and that'd be fine. It's not. In fact, I think, to be honest, it's probably better if you don't have the 1 there because it's just a little cleaner. So I like that idea. But it's so totally okay to have a -1 in front if you want. Either way, you have to have the negative. All right, let's see if you could handle 1 all by yourself. I did all of those and had you do them with me, but see if you can handle this one without my help. And pause for a second while you give that one a try. First thing, move the 2 over. Okay, so this one factors out this way. We factor out the 6 to the front, and then we do half and square on the -6. And the -6 becomes -3. You square it, makes 9. And then you need -9 here to cancel it out. Then because there's a 6 here out in front, we had to also multiply this by 6. And then this becomes -54 plus 2 makes -52. And this one factors to x minus 3 quantity squared. So there's the basics of finding complete the square, which finds the vertex, which would be +3, -52. And it also gives you the stretch factor. And it also gives you the axis of symmetry. Because if you know that the vertex is 3, -52, we should write that. 3, -52. Writing with my mouse is tricky. Then the axis of symmetry here would be x equals 3. You can take that from the x part of the vertex. All right, that's all I got for you for today. Save.